Happy weekend, guys. I'm just dropping in on my Saturday to run you guys through a quick little optimization workflow project where what we're going to do is over the past couple of days, today I went out and bought a tech deck because I spend a lot of time at my desk and tech decks are fucking sick. I'm getting better. Yep, landed that one. And I thought, when I get back into work, when I can use a 3D printer, I want to make a tech deck ramp with, included stair and rail. And someone on Thingiverse, Tito8Mind, has already modeled one of these up, ready for download, and I'll put the link in below. So I've just gone and downloaded that as an STL. And how, you might ask, how is this relevant to optimization, Darcy, or this class? Well, I will tell you that it is highly relevant because let me just import this mesh first. Because what we're going to do is, I'm going to 3D print this, but I want to work out the best way to position this ramp and rail and stair combo, so that it uses the least amount of support material, and that so it's cheaper to print. So we're going to run through a bit of a session to set up this workflow, and then use Galapagos to work out the best orientation for this print to get us the best result. So let's just start by bringing it into Rhino. And if you're going to follow along with this, I highly suggest you use a mesh that isn't too dense. Like 2,482 faces is a good amount. When you've got 1 million, that's probably quite a lot. So before we go any further, I have to remind you guys to, if you're liking these videos, remember to smash that like button or fucking grind up on it or ollie on it. You know what I mean? Because fucking skateboarding's cool. And so that, this content gets shared around. So why don't we start by what we're gonna do is essentially we're gonna find the best kind of orientation of this part to sit on a 3D printing bed, so that the support material that usually comes down from it is gonna be the least. So what I'm gonna do is sort of set up a series of rotations. So I'm just sort of getting this workflow up. We'll go from 0 to 359. We don't want 360 because it's essentially 0 in the XY plane. Cool. And then we're going to sort of daisy chain a few of these together. Like so. So we're going to take that result and rotate it, except we're going to change the plane to be YZ and then XZ. Bang. Bang. Cool. So the result should be, rotates around like that. I'm just going to hide this one. And then it'll also rotate like that. And also rotate like that. So essentially we have 3 kinds of angles that we can rotate this box around, which is great. And then let's sort of put that back on the ground plane. So I'm just going to put a box around it. Deconstruct domain. Where are you? There you are. I'm going to take the Z. Might want to put it a little bit above the ground plane. I think so. Don't mind me, I'm just getting this workflow down. Cool, so we're going to move this to yeah. Sorry, I'm just looking at my notes. Okay. Here, and here. There we go. So what that has done is moved it to... Oh. There we go. So it's like it's all I've done is just move it so we're sitting back on that ground plane, which is great. But we've raised it up, 2 or 3 mil, because what happens is generally when you've got a raft that sits underneath your 3D print. Can we just like orient this back down a bit more? There you go. So it's going to be sitting 2 millimeters above 0. Great. So what we need to work out now is we need to work out where all our support material is going to go. So essentially, we need to find all the faces on our mesh that point down, so we can kind of start to construct some fake, a bit of it, like give ourselves an idea of some support material. Like it's going to generally like be populated throughout these kinds of areas. And it's going to be straight extrusion all the way down. We'll look at doing that in the next video. So I'll see you then.